Now for number 12 on the final exam, you're going to have a choice of which ones to answer. Okay, so there's going to be, it'll ask you to choose one of the problems, so they're going to give you a choice on the final of which one to choose, and so you're just going to choose whatever one you want to work on. So I have a whole bunch of different parts that are on here, and so these are all different types of questions that you could choose from. So the questions you can choose from will either be related rates problems, or it'll be optimization kind of problems. So let's just go ahead and start with this one with 12A. So because you can print this out, I'm not going to write all this on the board. So it says the radius of a right circular cylinder. Now also you want to make sure on your note card you can put the geometry formulas down. They're on it, but actually for problems like this with the right circular cylinder, the formula would be given to you there. So for most of these ones, the geometry formulas, they should be provided for you on the test itself. So for this, the right circular cylinder is V equals pi r squared h. So that's the formula that you want to use. Now it says the radius of a right circular cylinder is increasing at a rate of 5 centimeters per minute. Now, if the radius is increasing, then what that is, it's actually going to be your dr dt. So that's going to be 5 centimeters per minute. So it's always good to write down the information that is provided. If the height is always twice the radius, okay, height is always twice the radius. That's something else that they tell you about this particular problem. Then find the rate the volume is changing. So they want you to find dV dt when the height is 8. So h equals 8 centimeters. Okay, so with this formula, the way it is, what we're going to do is we're going to do a substitution first. We're going to put 2r in there for h. Now the reason why is because they don't give us any information for what the height is changing with. And if you were to do product rule with this one, you'd have to do product because there's two different variables. And so you can make that easier if you make a substitution first, then you can avoid using product rule because then you no longer will have two variables on this particular question. So we're going to do V equals pi r squared, and then a 2r is going to go in there instead of h. Then when you multiply it, you're going to get 2 pi r cubed. And so that's your main formula that you're going to take the derivative of. So now we're going to take the derivative of both sides with respect to time because this is a related rates problem. dV dt is going to equal 2 pi r cubed. Actually, when we take the derivative, the 3 will come down. You'll get a 6 there. So 3 comes down in front. It turns that into a 6. This will be a square there. You just subtract 1 from that. Don't forget about this. This is really important. You have to make sure you put the dr dt there. So you do the regular power rule there. So 3 comes down, subtract 1, and you get this. But don't forget about that extra dr dt. Now, you want to solve for dV dt. That just means you have to just plug in information here. Now, we are given an h here, but we're not given the r. But you can use this formula right here in order to find the r. If h equals 2r, that means 8 equals 2r. If you divide by it, that means that your radius is going to have to equal 4, since we're given that the height is always twice the radius. So now we know a 4 is going to go in there. dr dt was given as 5, so we're just going to put all that in here. So you get dV dt is equal to 6 pi times 4 squared, and then times 5. And when you multiply all that together, that's going to give you 480 pi. So 480 pi would be your answer. Now, as far as the units are concerned here, your units were originally centimeters, so it's going to be centimeters cubed and then per minute. Volume has to do with cubic dimensions, so that's why it's going to have to be cm cubed, centimeters cubed, and then the minutes is the same unit of time that we had from dr dt.